Okay, thank you very much for Professor Han's introduction. And so today I'm going to talk about the climate change and also urban development, how they affect the design of infrastructure, actually the design standard. My presentation will follow as this. Climate change and how the urbanization would affect the heavy rain, and also how they affect on the urban heat island. So if you see the picture, you may see this is taken in this year, in July 20 and 20 something. So it's from Zhengzhou train station. Probably most of you already know Zhengzhou hit by the heavy rain in late July, and this is the recorded the largest or the most intensified rain in the world, as we have the record. So 1 hour, more than 200 millimeter rain fall in Zhengzhou and the city core of Zhengzhou. This the very extreme event. This is no doubt there's a climate change and the global warming. Recently, I think it's this week, COP 26, the United Nations has the climate change conference held in Glasgow in UK. So this is the right time we talk about climate change. So from the picture you can see there's a observed global and the annual average carbon dioxide increase since 1950. And also we observe and predict the annual average surface temperature increase if we compare with the baseline 1961 to 1990. This year, in 2020, we saw a lot extreme events, including the cold wave. You may recall in the beginning of the year, actually after the Christmas in 2020, and also the beginning of this year, many places got the cold wave, like Delhi in India. The recorded temperature is only 1.5. I recall I went to India in 2019, and around the same time, I can wear the short sleeve. But right now, but this year, the beginning of this year, the temperature dropped to 1.5. And also this happened in many places in China, like Shanghai, Yangtze River region, and also Guangdong. And this year, Guangdong has experienced not only the cold wave, but also the drought. So people may doubt why Guangdong has drought. Yeah, many reservoirs has a very low water level in Guangdong this year. And so we just talk about the extreme event occurred in Zhengzhou, and also we have a lot extreme events in North America. For example, the heat wave the hot wave in the West Coast, along the West Coast in North America. For example, the Seattle in July, the recorded temperature is more than 40. Seattle actually is very regarding the altitude. We can see it's on the high altitude. So normally the temperature is around, in the summer, the highest temperature is around 28. But this year, the recorded, the highest temperature is more than 40. So many people affected by the hot wave. So we can see there's a lot of things occurred. Many extreme events occurred this year due to the climate change. But what happened to the urbanization? We can see more than half of the world's population right now lives in urban area. And by mid of this century, let's say 250, the proportion of urban population will expected to reach 70%. So what that means? It means we are going to have more impervious area, and also we are going to have more infrastructure development. So what would happen? You will have more intensified urbanization and more impervious area. That's what we are going to investigate during this talk. We can see the poorly planned and designed urban development will increase the risk of climate disaster. So in this case, we need to investigate what the effects of the climate change and what would be the effects of urbanization on the design standard. So we did a study for Beijing because Beijing is a mega city, and we got some good rainfall records from Beijing. So here you can see this the point is the rainfall station, which we have data. And here, this the second rain. So it's the city core of Beijing. And this is fourth rain, and here this sixth rain. So the city was expanded this way. And here this this the mountain area, Yan Mountain, and here this the downwind area. And we did we use more than 40 years rainfall data, and we did some statistics for this rainfall data. The statistic we use, we call it L moments. So we use L moments to test the homogeneous area. So here, there's the L moments, including the LCV, is the variability, and also the skewness and the kurtosis. So what we found is the mean value for the is higher in the downwind area, and then is the urban area, and then is the urban the mountain area. So this the L moments we did. Okay. So for the L moments, to do the L moments, because by using the L moments as a tool, first we want to, because we want to investigate the effect of urban development. So we abstract the impervious area from 1980 to 2015. Then we found, so we plot impervious area like this. From this figure, you can see before 1998, there's a slow development, and after 1998, there's a very fast development. We also did some statistics, and the Petit test. We used the Petit test to identify the change point. So 1998 became the break point to separate the slow urbanization period and the rapid urbanization period. So by using that, we did a mapping. So from the map, you can see if we started on the heavy storm, means the storm larger than 25 millimeter per day. So we will see during the slow development period, the heavy rain falls in the northeast region. But after 1998, the heavy rain actually moving towards the city core, and also move towards the western area. The same thing occurred for the daily intensity of heavy storm. So if you can see during the slow development period, the heavy rainfall in this area, and during the rapid development area time, the heavy rainfall into this area. So this is a area between the mountain area and also the plain area. As we said before, we also did a homogeneous test using the L moments. This is before 1998. This after 1998. One very interesting point we found is before 1998 is the slow urbanization period. We have only two homogeneous area. One is the mountain area, and the one is the the plain area. So that's very easy to understand, right? Because in the morphology has a big effect on the rainfall. So we have two areas. One is in the mountain area, and the one is here. However, after 1998, we found there's additional area occurred. It's between the mountain area and the plain area. Why this happened? Oh, let's go back. Why this happened? Okay. And what would have the effect if we have three areas? If you see this figure, the figure shows the design storm for 50-year return period. From this figure, you can see for the period before, for the slow development period, means before 1998. We have two regions, and this the IDF curve for this two regions. But after 1998, we have three regions, and the daily rainfall in the region 1 and region 2 has increased by 35 and 19 millimeter. However, However, the for the region 3, there is a big increase, 86 millimeter. So this is the western of Beijing. This increased the most. 2 weeks ago, I also did a presentation in Beijing, and I have a discussion with some people in Beijing. What they said is in the western area, normally here, is higher. But recently they experienced more flooding in this area. So you can see the additional homogeneous area occurred after 1998, actually has more effect by the urban development, because all the region 1 and the region 2 and the region 3, they are in the same in the same area. They should experience the the same effect of the climate change. So the extreme event is not brought by climate change. It's brought by urban development. As also, if we do the mapping of 20 years return period to our storm, what we can see after 1998, the center of heavy rain moved due to the development in the western area. So they moved from here to here. The center moved to here. If we do the 24 hours, we found about the similar trend. The center of the heavy rain moving from the eastern area to the western area. So make a summary. We can see the Mac City, the development of Mac City has changed the spatial temporal distribution of the heavy rain, as well as the extremes. So as we said, as we see the in the region 3, we saw the region 3 has more extreme value. So in this case, we can get a feeling for the infrastructure design in the future, especially for Mac City and the city clusters. The synergy of climate change as well as the urban development on the rainfall should be considered. This means we may need to develop some new design standard to accommodate the climate change and also the urban development itself. Then we will raise a question, why does the development of Mac City cause change in the temporal and the spatial distribution and the extreme values of rainfall? What are the driving factors? So to answer this question, we also did some research on urban heat island because many people has said the urban heat island may have the effect on urban rain island. So to do the study, we use the satellite picture in August from 1984 to 2012. So from here, from this figure, you can see this is the comparison of urban heat island. This is a within fourth ring, and here this is outer sixth ring. Here, this the this is between fourth ring and the fifth ring, and this between the fifth ring and the sixth ring. Here you can see this the imperfectness before and after 1998. The area in red is before 1998, and the yellow, yellow color shows the imperfectness after 1998. And the urban heat island, normally we use the difference between the core, the city core, and the suburb, the surface temperature between the discrepancy of the surface temperature between the core, the city core, and the suburb. So from here you can see the highest urban heat island occurred in fourth ring and between the fourth ring and the sixth ring. So this also we can see from these two pictures. So then we found from the literature, it says the urban heat island effect increases the thickness of the atmospheric boundary layer and the height of the free convection. This will increase the convective activity. The thermal transport triggers water vapor transport and the convergent ascending motion. So here is the special characteristics of the higher rainfall. So we can see here this Yan Mountain. So has the high elevation here. This is the urban region. So because the heat island effect, we have a turbulent occurred in here. And then here is the downwind area. So when the turbulence happened here, and then they reach the high elevation, the water vapor may stop here, and form the rainfall fall down here. So the mountain valley breeze circulation between the urban region and the western and then northern mountains may superpose on the urban heat island circulation for the enhancing the convection motion. So this explains the urban heat island might be the driven force for the third region of the homogeneous region, and they may increase the extreme of the heavy rainfall. We have published the results in urban climate. So if you have interest, here is a link for this paper. So give the conclusion. The synergy of the climate and the urbanization has significantly changed the characteristics of the heavy rainfall. So we can see the homogeneous area has been changed. The heavy rainfall became more extreme after the rapid urbanization. So this means we need to consider to update the design storm more frequently in order to combat the flooding induced by the extreme events. So when we update the design storm, we need to not only consider the climate change, but also consider the urban development itself. Okay, to finish my presentation, I would like to use the quote from Gilbert White. He said, "The floods are acts of God, but the flood houses are largely acts of men." So this means we need for more sustainable development, we may need to consider how we build the infrastructure, and we need to consider the design storm, the standard, how they would fit into the future development. Okay, thank you very much. This comes to the end of my presentation, and thank you, everyone.